ございます。AEC インダストリー、東京 AEC インダストリーデブグループっていうミートアップをしているんですけど、毎週、土曜日にこうして集まっています。いつもハンズオンで1時間半ほどハンズオンしてもらってから、交流30分みたいな感じで、自己紹介を後半の30分でやっているんですけど、今日はトロントからマフィーさんがいらっしゃったので、プレゼンテーションを聞いて最後に交流みたいな感じにしたいと思います。で、今日はちょっと英語なので、レンさんいらっしゃいます？レンさんいます？
はい。
レンさんちょっと手伝ってもらっていいですか？
はい、
ちょっと
OK です。
英語の進行ちょっと手伝ってもらって質問等あったら日本語で投げかけてもらってトランスレーションをちょっとレンさんが完璧にトランスレーションしてくれるので。So today's session we have Ren. He is very good at English and Japanese as well. So if you
Hello.
have any question in Japanese, he will translate for you. So we have a special help. So, okay, じゃあ okay, let's get started. So please welcome Matthew-san, everybody, and じゃあ please give us presentation, Matthew. Thank you.
Sure. Well, thank you so much, Yuko, for the invitation. Very nice to meet everyone here at the meetup, and super excited to tell you about generative design for AEC. This will be a bit more of an overview and some case studies, mostly from the technology centers and Autodesk research. So also, it is fun to say that it is Halloween. Today is October 31st in Japan. So for those of you who are celebrating Halloween, happy Halloween. If you are dressing up, have fun. It'll be super great. Okay, so this talk is going to be about learning if you wanted to ever create lots of design iterations and you wanted to automatically create lots of design iterations and understand how well they perform. So how do you do this? This is going to be the essence of the talk tonight. And I can say from myself personally, I wish I had access to these kinds of tools and technologies and approaches for my own work. So who am I? I am an engagement manager with Autodesk Research and the Technology Centers. I'm based out of Toronto, Ontario, Canada. And I'm also a teacher. I teach at the University of Toronto in the Daniels Faculty of Architecture, Landscape, and Design. I'm trained as an architect, specializing mostly in computational design, fabrication, and landscape interests. I also have some certifications in digital fabrication and CNC tools. I've done a mixed background in practice, mostly in experimental research and some interesting consulting with manufacturers. And as I mentioned, I also teach University of Waterloo, Toronto, and MIT's Center for Advanced Urbanism. So generative design for me, I can always say that I really wish I had these kinds of tools. These are some examples of my previous work. This is when I was with an office called Lateral Office, imagining what Canada's Arctic would look like from a design perspective. And you can kind of see that a lot of the designs are meant to have a performance element. How well will the structures perform relative to wind or snow or sunlight? And in a lot of cases, I was not able to explore many options, or us as a team were not able to explore many options because we didn't have the tools to make lots of iterations quickly. This is similar to the work that I did at MIT. We are looking at what the future cities will look like under challenging conditions, in this case with sea level rise and climate change. And the same situation, it was how can we find automated solutions to create many design iterations? And finally, I was also working with a research group called Living Architecture Systems. And it was a similar challenge. We were making these interactive and quite immersive installations. And the challenge was, how do we balance the goals of having these pieces be interactive? You can see with the audience below, along with fitting into the space and performing to a degree with the environment it was put in. And as you can imagine, with all this detail, it was very challenging to make iterations. And that's why generative design would have been also handy in this situation. As I mentioned, I also teach at the University of Toronto. Oh, hello. This is the department that I teach in. And I mostly teach in the Master of Architecture, Landscape Design, and Urban Design. And it's here that I teach a lot of performance-driven design as a overall philosophy. And generative design comes into play when I'm trying to explain to students how they can leverage parametric design tools such as Dynamo or Grasshopper to be more useful for a goal that they're trying to achieve. And now I work with the Autodesk Technology Centers, and I'll talk about what the technology centers are, but I helped found the Toronto, Canada chapter technology center, where I get to work with people like here on the right, explore their designs and innovation projects. And in some cases, I get to introduce them to what generative design is, both at the kind of product design scale and at even more large scale, such as in AEC. So my role with the technology centers is generally bundled under what we call Autodesk's Chief Technology Officer, or CTO. And under the Technology Center, I help run an open innovation and residency program that we now call the Outside Network. But there's two other levels in which Autodesk CTO exists. And I'll talk about the Industry Futures group in a small while. But I will say that our group with the technology centers is extremely externally facing. We work with a lot of customers, users, academics, and I'll talk again about this in a little bit more detail. Without describing too much about what each group does, I'll just give an overview that the science teams are mostly interested in doing research for papers, patents, prototypes of new software. The industry futures team that we'll talk about a little bit further, they're mostly working with customers on what we call lighthouse projects. These are very high profile projects that push research, but also are grounded very much in a real project. And as I mentioned, I'm part of the technology centers that helps a very wide spectrum of teams and a very high quantity and volume of teams to achieve their innovation goals. So now that you know a little bit about me, I'm going to talk about what we're going to cover in today's talk. So first, we're going to talk about what even is generative design. Why is it emerging now? Why does it exist in 2019 and 2020? Why does it come up? And what versions of generative design exist? Then I'll talk about, great, we have this approach and these technologies. How are people using this to solve real problems? So we'll go over some case studies, both from Autodesk research and from some of the residents that I mentioned in my technology centers. And finally, I'll talk about tools. How can you start experimenting with some of these generative design for AEC experiments? We'll cover mostly Autodesk Refinery, which is the generative design or generative algorithm engine. But there's also some adoption into Revit 2021 that makes it very easy. And I'll talk about one case study where that is possible. And finally, I'll talk about how you can get involved with Autodesk. We'll talk about the technology centers and how you can experiment with generative design if you're interested. As Yuko mentioned, today's class is not going to be about a tutorial. It's more about examples and case studies. So if you're interested, there's many courses I can point you to from Autodesk University or other things that I can talk to you about after the class. So, okay, without further ado, section 1, what is generative design? So for some of you that are new to this, I like this analogy that one of our leaders from Autodesk in the AEC group, Zach Krohn, calls farming for forms. So hold that in your head for a little bit. We'll come back to that analogy, but I really think it is very potent as an idea. So for those of you that are new to generative design, you may have seen and you may have been hearing about a lot of projects that are using the tools and using the approach. One of the more popular ones that came out in recent time was a project done with Philippe Starck, the industrial designer, interior designer, and architect, who was able to design this chair in collaboration with Autodesk Research and new generative design tools. The challenge with this project is that everybody was starting to add in extra expectations. There was a lot of misinformation. People were saying, is computers going to take over designers' jobs? And it was generally a little bit not well understood by the general public. So what I like to do is generally frame generative design as a meta level of design using artificial intelligence. And I like this diagram that basically shows the different layers of AI in design. And to basically find that generative design is somewhere in this level. So it is basically the use of genetic algorithms to help make decisions in finding higher performance design options. So I just like to clarify that it is not machine learning, it is not deep learning. This is what deep learning looks like for architecture. It's basically being able to leverage lots of data and being able to make predictive models in the future of something that is related to it. Generative design, we will see, behaves very differently. So how did we get here? How did we get to generative design? Here's a little history that Autodesk likes to share, which is that traditional design with the computer really was starting around the time of computer-aided drafting and design. This can be likened to tools like AutoCAD, where you would draw something, it was explicit, and you couldn't modify it easily. There were no associative rules. And then we entered a different era of design called parametric design, which many people are starting to adopt and become more comfortable with the approach even now. This could be through tools like Revit or even visual programming languages like Grasshopper or Dynamo. And we are now entering another age of design that we are calling generative design. This is even further away from the other explicit modeling tools where you are describing as a designer goals and constraints, and the computer, or more accurately, the software, will come up with options for you or will optimize for you. And so this is what we're going to talk a little bit about further into the talk. Another way to look at this topic is to basically look at it from a mixture of history and theory and different movements that have contributed to this period we're in now, stretching all the way back to Walter Gropius and Le Corbusier, Buckminster Fuller with modularity concepts, stretching into parametricism and all the things that feed into what we now call architecture and AI. I like to pause here and to say that generative design is not just about tools, though. It's really a design process, and it's really a design approach. In my opinion, it is really founded on 4 core technologies. There is parametric modeling, things that we're used to, like Revit, Dynamo, Grasshopper, tools like simulation packages. This could be like Ladybug or Honeybee, packages that help you understand what the performance of your design is. Optimization tools, and we'll talk about that further. This is where the genetic algorithm comes in. And finally, some data visualization tools to see all of the different iterations you might have made. So I'm just going to go over a very brief history of fundamentally going from the 1910s to the 2020s and focusing mostly on the parametric modeling history and the optimization engine history, because the simulation tools can change and can adapt and can be modified to your needs, and so will the data analytics. So the parametric modeling history can stretch back, I would say in kind of analog and physical forms to 1905 with Antoni Gaudi's funicular maquetas. These are basically these physical models that helped him, like a Grasshopper script or a Dynamo graph, pull on the different forms and see the impact that it has with these pulleys and weights. Skipping ahead into history, after we get tools like Sketchpad or AutoCAD or SolidWorks, we really start to see visual programming, a combination of explicit modeling and associative rules, show up with Bentley Systems generative components. And then, of course, tools like Grasshopper and Rhino show up very well with the plugin Explicit History in 2007. And with Autodesk, we have the Revit tool come out in 2000 and Dynamo come out in 2013. So we know what parametric modeling is. What about optimization? The evolutionary aspect of generative design is truly critical, that allows designers to spend more time generating forms and seeing how they can lean towards higher performing options. The key thing here is that the computer needs to help decide which option is better performing. So this is where the intelligence aspect comes into play. And there's 3 figures that are really important to this history. The first, I would say, is Alan Turing, who basically proposes the question, can machines think? And is really seen as one of the early fathers of artificial intelligence. Frank Rosenblatt is an American psychologist who positions the idea that there could be a computer that can make informed decisions. If they're given enough information, they can pick better candidates over others. And finally, we have John Holland, who only recently passed away, but is an American computer scientist who invented the idea of the genetic algorithm. And he basically proposed the idea that this genetic algorithm would be comprised of 4 primary principles: reproduction, selection, crossover, and mutation. And these are the 4 core principles behind all of the genetic algorithms we use today, whether it's Wallace-E for Grasshopper, Discover for Dynamo or for Grasshopper, Galapagos uses the same principles. It's basically all there from this one person. So again, the recap is that we have these 4 core technologies, and they're all coming to maturity now, 2019 and 2020, so that everyone can combine them together to make what we call generative design as an approach. So this is where I like to return to my analogy of farming or agriculture. If generative design is about making geometry and then evolving or optimizing the options, it's kind of like farming. Although in this case, we're not farming for food. So what's a good Halloween reference for today? Let's take a look at the case of a pumpkin. This is a very popular vegetable in North America around Halloween time. And in this case, there's something I want, there's a goal. I know that nature is making all of this stuff. They're making lots of different pumpkins. And if we manage pumpkin patches and agriculture, we can slowly get to the perfect pumpkin that we like. So here is it broken down into generative design pseudocode. We have a goal of our pumpkin. We have generators, seeds, soil, sunlight, and we have evaluation tools. We know what color we want it to be. We know what kind of density we need it to be in order to be ripe. And we know if it is ripe also by having the tendril at the top being dry. So this is kind of like metrics, goals, if you will, that help us understand the quality of a pumpkin in quantitative measures. So how are people using generative design? It's great that it's evolving as a technology and as an approach, but how are people solving problems with this? So first, I'm going to share some examples from Autodesk research. And I'm going to cover out of these 4 examples, I'm going to talk about 3 to give you an idea. And I like these 3 because they scale in terms of the goals. So this was a very early project using some tools where there were 2 goals. The office that I work in Toronto, we used the same technology to design our office. And here we were using 6 goals. And another project, we partnered with one of our customers called Van Wijnen. They are a Dutch housing company. And there we wanted to lay out a neighborhood. And we had 7 goals. In this case, including cost and profit into the model, which was a first. So let's talk about these in a little bit more detail. Let's talk about the Airbus Bionic partition. Some of you might have seen this example, but I'll go over it again for clarity. So Airbus came to us with this amazing project. They're like, this is what we want the future of airplanes to look like. We want it to be very lightweight. We want it to save lots on greenhouse gases. And we want it to feel very open, lots of windows to see the outside. And we decided, cool, that looks amazing, but maybe we can start with a smaller project to be more real. So we decided to take a look at this, which is a small partition, a wall, an architectural feature even inside of an airplane. So in this case, if you've seen the Airbus models, this is where the cabin crew sit down. And normally this is made of sheet steel and it's capped off with a few different panels. It's a very dead weight and heavy component. So we decided to think a little more creatively about it, which is to break the profile down into its outer profile, and then think about how we could stitch together different trusses in between it structurally. And then let generative design find an option that would be a good balance between weight, how heavy it is, and displacement. So I'm going to put it here to pause to show you this is one goal, displacement. This is how far the wall will deflect under load. And we want this number to be small. And then weight, this is another goal. We want this number to be small as well. But if you make it too lightweight, it will displace more. So it's a trade-off. There's going to be lots of different options. These are all of the different iterations that were made. There were 10,000 designs that were automatically generated. And here you can see some of them highlighted. Here is weight, and on the bottom towards the right, they get heavier. And you can see that the displacement is very low, which is great, except that they're too heavy. And then here you can see that there's lighter options, but you can see that the displacement is very high. So there's a nice mix somewhere in the middle. And so this is where generative design can help you find options that are high performing and are maybe unique in the way that they are solving it. This is an example of the piece when it was finally completed. It was elected to fabricate this wall using 3D printing technology with metal. And so that's why you're seeing these little knuckles here. That's the edge of the 3D printing box. And they're starting to test it right now. So it's being experimented inside the plane for future use. So the next project is Autodesk's Toronto office. And here, in this case, we had to move from an old office with brick and wood into a brand new office in the center of the city in an innovation district. We moved from this area of Toronto to closer to what we would call the innovation core of the city. And here you can see that we basically were occupying the first 3 floors of this building. And when we were making the move, we wanted to interview all of the Autodesk employees. What do you prefer when you are coding, when you are making your products, when you are designing tools? We have lots of different products that Autodesk offers that are being developed in Toronto. And so each of these different groups had different preferences. So we interviewed them all and got all of their different specific attributes of what they preferred in terms of lighting, acoustics, comfort, noise, things like this. And we were able to combine them all and distill that we had 6 goals that we wanted the design of the office to try to achieve. These were low distraction, so being more quiet, adjacency preference. This is basically having connection to your teammates. Interconnectivity, this is kind of in opposition to low distraction, being close to different areas. Daylight, which is fairly straightforward. Views to the outside with the windows, and work style preference. Each of these goals needed to have a quantitative, numerical way to break them down. And so for each of these, we had an equation, a scoring equation that would then get normalized as a value out of 10 that we could score each design. So in this case, there were some inputs and there were some outputs going from a score from 0 to 10. And here on the right, you're seeing essentially what this custom simulation tool is doing both graphically, and there was a numeric value. Here's what work style looked like: interconnectivity, low visual distraction, and daylight. And finally, views to the outside. So it was great that we had these goals. And now what we needed was an architectural concept to tie it all together. And so we really like the idea of thinking that an office is like a small city. A small city has lots of neighborhoods, lots of different districts. And so that's what we would make each of the product teams. So for example, here there's a group working on Fusion 360. Here is Autodesk Research. Here is Autodesk Sketchbook, Alias Automotive Tools. So each of them had their own specific area. And how did we imagine this coming together? This is basically how we laid out the geometry of the office. So we basically had the initial conditions of the office. We had some zones that we could not touch in gray and a main path. Each of the different neighborhoods had a center and could move back and forth. And it would make essentially the cell of a Voronoi that would make the edges of these neighborhoods. And they could move around, they could shift. One edge of the neighborhood would have what we called an amenity area. This could be a lab, this could be offices, meeting rooms, VR labs, things like that. And then we would lay out the desks afterwards. And each time we did it, you could move these around and it would automatically update all of the goals. So here on the right, you're seeing what those look like. And here's this little animation of blocking it out, laying the spine, putting the centers with the Voronoi, letting the amenity bar show up with the meeting rooms, desks, and then seeing the goals each time. And then we let the algorithm run. And the algorithm ran 10,000 times. So we had 10,000 floor plans to choose from. And always with the genetic design or generative design, there's the challenge of what do you do with 10,000 options? So this is where the data analytics tools are helpful. Here you can see all the different iterations getting plotted on the goals of circulation or views, and you can see how they look like when plotted on this graph. Once we selected one version, this was again interviewing all of our employees and seeing which ones they like. We were then able to take a final version to completion. So this is what our neighborhoods looked like. And we finally took them into Revit for detailing. And now we're all moved in and we are almost 3 years into this project. So a lot of people will ask if we like to modify it. And that is an ongoing research project to see if we can monitor the inside with sensors to see if we can pick up data that would adjust the interior. And if you want to experiment with this graph, I can share with you a link afterwards. We made this Dynamo graph public, so you can access it. one of our researchers has shared the entire Dynamo graph on his blog called Through the Interface, and it's called Project Rediscover. And I'll share with you the link after, and you can play around with the Toronto Autodesk office. And if you're wondering, I sit right here, if you ever want to mess around with my office. So a final project from Autodesk Research is with this group that we worked with at an urban scale called Van Wijnen. Van Wijnen is a Dutch housing company, and they make prefabricated homes that are modular. They're very forward thinking. They like to use augmented reality to see how to lay out the mechanical, electrical, and plumbing of all of their prefabricated components. And they like to experiment with technology even at the larger scale. So this was one place that they wanted to introduce a design, and they wanted to use generative design to imagine lots of design options. So really they have 3 units that they work with: a single story unit, a double story, and a triple story unit. The trick is, where do you put which units on the lot? So we needed to understand, like the Autodesk office, what are the constraints? What can we not touch? And what are the things that we need to stay or stick with? So in this case, like before, we also came up with goals, and we had to find ways to measure those goals. So here you can see all the iterations and how they are scoring. This is another on the left way to represent goals. This is called a radar graph that shows you on a scale of 0 to 10 how well each one is scoring. And again, we let the algorithm run. In this case, we had, I think, 20,000 iterations. So again, lots of designs. And similar, in this case, you can see the data analytics technology is getting better and better. This is now using Autodesk Refinery as a tool. So it's no longer Autodesk Research. It's now an Autodesk product. So here's different ways of seeing the designs and them being laid out, and how you can organize them on an X and a Y axis, as well as with size. So the bigger the circle versus the smaller, and the color. So lots of ways to see your design ideas. Like the other projects, we selected a few candidates that were well performing. There isn't one good one. There's usually many options. So we had to take a few options and go back to the customer and say which ones make the most sense to develop. So Van Wijnen was so happy with this process that they wanted to turn this into a tool that they could use for any site. So they wanted a generic tool that they could apply to new projects. So here's a new project that they wanted to look at. And they had a simple boundary with access points as a green zone for trees, and their kit of parts, the houses. And this is what the Dynamo graph looks like in order to create this inside of Dynamo. And it works very easy. All you need to do is give it an AutoCAD 2D plan of the site, and then Dynamo will read that plan and start to populate all of the stuff inside of it. So here you can see they are starting to experiment with different layers for green zones of what the script cannot touch, the exclusion or the constraints. Like before, You select a design, and then you can take it into Revit for detailing. This is now what it looks like as a real project. Again, this is moving away from research and moving into product. So if you have played with Dynamo and Refinery, this is exactly what you will see. You will see the graph and able to change the color and the size and the X and the Y. You can also visualize things with a parallel coordinate plot, and you can see all the designs when you click on them. So the process is usually where you have your constraints and requirements and you generate a form. You then see how well it scores to your goals, and then you evolve the design over and over until you get options that you really like. So how are other people, how are customers using this who are not related to Autodesk research? These are examples that I've helped in our residency program at the technology centers. The first is a short video that I'm going to let play. Let me know if the audio comes through. Can you hear? No? Oh, darn. Okay. Okay, I'll talk over it. Sorry about the technical problem. So what we did is we ran a 2-week program in Toronto where we invited 6 teams to come in to try out the software. So we had University of Toronto professors, we had people from MIT, we had Arup Engineering, we had a construction company, a Brazilian startup. So lots of different groups, a very wide spectrum. And we wanted to see what they would do with their projects. A way to get feedback on the tool and to get a chance to see what people would solve with the new approach. So we ran it at our technology center in Toronto, and I was working with some collaborators from research to work with all of the different participants to come up with their designs. So we had Arup in Toronto, MIT, University of Toronto in Florida, Broward County, Hone Structures from Brazil, Dar and Parsons Group, and another group from Dar to join. And I'll talk about a couple of these projects because maybe these are similar to challenges you have. So with Parsons, they are a big construction and contracting company working mostly out of the Middle East. And they had this big project, a master plan for a city in Ream Island. And this is what it will, an artist's conception of what it will look like. But they knew that it would be broken into these general quarters or neighborhoods. But they needed to know what each of these blocks will look like. So towers and podiums, how does it work? How should they be designed? So there's many options that they could pick. 1 tower, 2 towers, mixed podium. What's the best solution? And they decided to look at all of these different options in Dynamo and then be able to essentially test them according to goals related to sun analysis, courtyard size, sun exposure, views, and how much gross floor area or GFA they should include. So here are some examples of them looking at a podium plus a tower and seeing how well it scores to main attractions for views. And the second goal that they really wanted to get, because it's in Abu Dhabi and Dubai, they really needed to make sure that the courtyards would not be too hot to be comfortable outdoor space. A second team was from Brazil. They're called Home Structures and Bravo Engineering. They really wanted to make expressive, occupiable trusses or concrete beams. And they thought that this was a great aesthetic to pursue with both architects and engineers. The challenge is, how do you lay out the rebar or the reinforcement bar inside of these uniquely designed trusses? So they brought it to a research level where they wanted to take a simple object, apply a load and a obscuring feature, and then find the most optimal shape it could take. So here they're experimenting with some of our other tools in Autodesk. This case, it's Fusion 360. And they're using Fusion 360 to apply a load and then see where the predominant stress lines will show up in that wall of potential concrete. Once they had that shape, then they brought that shape into Dynamo as an input, as a Revit geometry piece. And the output is that they wanted to have the minimum rebar reinforcement. And in the middle, they made their own custom Python node to help lay out where the rebar should go. So in the end, they were able to finish their script, which was great, and start to make prototypes, physical prototypes from this experiment. Speaking of concrete, we have other construction companies using the same technology now. So in North America, there's still the preference to have concrete laid out with formwork like wood structure, but people want to start getting to 3D printed formwork. So we have a construction company in the program that has tall towers, and they want to know what is the best way to lay out the formwork for uniquely shaped towers as they go. So in this case, this is using Revit 2021, and you can see that now you can access generative design right inside of Revit. This will take you, so you don't even need to use Dynamo if you have a simple program. In this case, they broke the tower down into the profile, and they were able to see what the supporting buttresses of the concrete should look like. And they needed to know, if they're going to 3D print this formwork, what is the optimal geometry that this formwork should be laid out as. So here they want to minimize the shortest pieces. They want to reduce the amount of 3D printed pieces. They want to minimize the unique pieces, so reuse more and more pieces, and minimize the volume. And you can see here they're using Refinery in order to get an option for the concrete. Once they had the design, we brought it into Fusion 360 so that they could fabricate these models. So here we're just using it to create a slicing pattern for 3D printing. And we're going to experiment using a robot in order to 3D print that formwork. And here is it being printed in real life. And one of our technicians is just checking the temperature to make sure it doesn't overheat. Okay, so I'm going to take a quick break, And Yuko, maybe we could just ask everybody if they have questions so far,
Sure.
or if they have ideas about what they would maybe use generative design for.
Yeah, sounds great. Okay, thank you for the presentation. The half and okay. So ちょっと日本語で Okay, sorry, I will use Japanese to
Sure.
ask questions. じゃあ、何か質問やここまで見た中でアイディア、こういうふうに使いたいなど、ございましたら、今から少し5分ほど質問などどうですか、いかがですか、皆さん。こういうことに使ってみたい、こういう事例のここの質問みたいなのありましたら、どうですかね。あらら、レンさんどうですか？
Hi, can I ask a question?
あ、カドさん。いや、
Yes.
Okay, so thank you for your presentation. I'm just feel like this generative design is like a multi-parametric modeling. Right?
Yes. Multi-objective optimization.
Okay, so but a lot of things what happened in real world is we can't evaluate like by formula or something. Yeah, how do we approach this kind of uncertain things?
That is a really great question. So this is what we talk about in the applications of generative design, having a quantitative goal versus a qualitative goal.
Mm.
So I'm going to just go to this point here and show you. So here's a good example. In real life, we had our Autodesk employees say that they wanted something called adjacency preference. What is adjacency preference? It's not like daylight or views to outside. These two are easy to measure. They have tools and plugins that can be easy to adopt into the workflow. But something like adjacency preference and interconnectivity are very subjective. And so we needed to take it from a subjective idea and we needed to turn it into something that could have a formula. So you do need to try to find a way to turn it into a quantitative formula number. This is where the art of designing with generative design comes from. It's a challenge, everybody knows, but that's the only answer that I have for you right now, is that we had this thing which was shortest path plus a vertical multiplier. We had to come up with our own tools to measure what adjacency preference could be.
Yep.
Similar to work style. Work style is very subjective. Everybody has a different idea about what work style should be. So in this case, we needed to make a combination of quantitative measures in combination. So in this case, it was lighting, preferential lighting plus activity, and that could be divided over some kind of common baseline feature. So it's our interpretation.
Yeah. So if client or customer want to change this kind of equation, the tool can change the formula.
Yes, so let's say we are looking at our dynamo graph. So each of the goals, you would, if it's a custom equation, you would make that custom equation inside of an equation node inside of Dynamo, or something like a Python node if you wanted, or you could build it more manually with lots of different nodes together. But you can change it, of course, at any time. It's just how you want to measure each of your designs.
Okay, thank you.
Thank you. That was a great question. It's always hard to work with quantitative, qualitative measures. Does anybody else have a question or a comment?
他の方どうでしょうか。日本語でも大丈夫です。
ああ。どう？
どうですか。千夏さんなどどうでしょう。いかがでしょう。
It's okay. If there's nothing right now, I can continue.
Okay.
Okay.
英語苦手なので、すいません、あんまり。
すいません。
はい、すいません。
大丈夫です。
でもレビットでジェネリティブデザイン使ってるのがすごい面白そうでした。私、レビット普段使ってるんですけど、ちょっといまいちまだあんまり使い方が分かんなくて触れてなかったんで、触ってみたいなと思いました。感想になっちゃったんですけど。
はい。Okay, she's using a lot of project in Revit. I know her because she's teaching Revit in Japanese, and she has a lot of experience in Dynamo. But now she interested in generative design in Dynamo. That is her comment. And okay, yeah. Also, I have a question so far, and thank you for the presentation. And there's a lot of possibility how we use for generative design. But I have a question for each project. How do you divide the tasks? You are making Dynamo code for goals, each goals, and I'm interested in how you work as a team to develop this Dynamo code, because for me it's really difficult to divide the task in Dynamo, and we have always run out of time because the Dynamo coder is only one person, or we cannot collaborate well. And that how do you experience that?
That is another great question. So usually what our research teams do, let me see here if I can find a good example. Yeah, okay, let's see. Usually what we do, I guess the office is the best one I can think of. So we usually like to divide it up into two primary tasks. Task number one is to come up with the geometry system. This is like parametric modeling. It's really no different than what you would normally do with Grasshopper or Dynamo. Someone needs to have the geometric rules for how the design should work. That's usually one team's task. They just experiment with the geometry. The only special consideration for generative design is to make sure that if the algorithm runs automatically, it will not have a null condition. So this means that it will not produce geometry that is going to result a bad value later. This could be like a value of 0 or a null condition in both Dynamo or Grasshopper. That's one team. The second team is to do what we were talking about here, which is to understand the goals. how do you measure if your project is performing well? This is one team's task completely. They either find plugins or packages or add-ons, or in the case of these instances, they came up with their own tools, their own way to measure performance. So those are usually the two primary teams.
Mhm.
One to make geometry and one to score the geometry with the goals. And these two teams work together.
Right. So in this project, how many people working on Dynamo programming, I would say?
In this project, there was like 4 people.
4 people. Okay.
So 2 people to come up with the architectural idea
Mhm.
and the geometry. So in this case, let's see here. This idea of the city
Mhm.
inside the office,
Mm.
that plus the geometry is 2 people, 1 team
I see,
geometry
I see.
system. And then the goals was 2 other people.
And how long did you spend time for this project? Just writing code, the time for developing this system. How long do you guys spend time?
I don't know. I would have to double check with the research team. I know the whole process to interview people
Mhm.
and to get the scores,
Right,
that
right.
took many months.
Yeah, I can imagine. Yeah,
Yeah.
that is the most the time consuming part, I think.
And then the design of the layout itself, especially with the more simple goals like views to outside and daylight, probably only a couple of months,
I see, couple of months.
maybe even shorter than that.
Mm-hmm.
But it was really these other goals that were harder to calculate.
I see, I see.
And then each time you make a design, you want to test it with the genetic algorithm
Right,
to see if it's giving you good results. So you usually, at this time, this is now like a 4 or 5-year-old project. It took many times to like get 20,000 iterations.
Right, right, right.
And you'd have to see which options were good or bad.
Yeah. I see. Yeah, many clients for me, they really want to try this generative design, but always I try to explain them how many people we need and how long, because generative design you need to have iteration, and if the task is bigger and model is bigger, the each iteration takes time, so it's not like you know, like a video, like the video they saw is 5 minutes,
Yeah.
and they have like
Yeah.
20,000 result, and they think, oh, that is really cool and easy to get a result. And I always explain that that is not the time you uh, making a project. It's the time
Yeah.
to see the result. So it's not like a couple of hours you get the to 20,000 result in one click. It's a long time to
Yeah.
get that good
Like in
result.
this case with the construction company, it was, well, I mean, this team here, it took them to develop their script
Mhm.
to understand what goals they wanted
Mhm.
and how they were going to do the whole
Right.
project. It took them about I would say 2 weeks to get to this result.
Mhm. 2 weeks for the result.
Hmm.
That's interesting. Yeah, that's really a great presentation that you explain generative design as a metaphor for agriculture. So you can imagine like agriculture, you don't expect how the thing grows and the
Yeah.
temperature and weather it's affects. So you always cannot expect perfectly the result. So it's the explanation was great. I really want to use that metaphor for my client as well. Thank you very
Great.
much.
Yeah.
Okay.
And well, I mean, for those of you that are interested in the tool itself, I can talk a little bit more about how Project Refinery operates in Dynamo, if that's interesting.
Yeah, I think all of us are really interested in those as well. I think most of
Okay.
us is Dynamo user, but in
Oh,
Japan,
okay.
there's not many project in Dynamo, so we more like experiment ourselves, not real project though.
Okay.
Yeah.
Yeah, so I mean, Dynamo, if you're familiar, sounds like everybody knows it. The way that I usually like to explain what generative design in Dynamo is that it's an extension to Dynamo 2.0. So you can now access it as a public beta. If you want to experiment with it in Dynamo, if you have Revit 2021, it comes already inside. It runs locally, so it's not using cloud processing, which is good. That way you don't have to like borrow Amazon Web Services or something. And it uses the same algorithm that was used for the Autodesk Toronto office. So the same results that Autodesk Research used, you have the same tool, and it made a real project. And it can sync designs back and forth between Dynamo and Revit. There are some pretty easy case studies that we provide new users on the beta. There's like what we call the 3-box problem. It's like you have 3 masses of a building. How big should they be relative to each other for volume and surface area? But when I usually like to lay out designs in Dynamo, for generative design, I like to break it down where I have all my inputs, my parameter values, and all of my preferred metrics or performance metrics at the end. And then analysis and display and geometry is somewhere in the middle. And Dynamo will treat Refinery like a stand-on. So the Refinery window will pop up on top of your Dynamo window, and it will say, great, you want to create a generative design study? Tell me, what are the inputs? What are your outputs? Are there any global settings? And there's an issue log for you. So your parameter values are your inputs, your performance metrics are your outputs. Everything else is fairly straightforward. Usually the analysis, this is where those formulas come into play, like how to calculate daylight or how to calculate something else. And then in here, the output is just a final number, just a quantity. It has to be a number so that Refinery knows if it needs to maximize or minimize a value. So in this case, with the 3-box problem, we can basically see that Refinery will take all these inputs and play with the sliders on your behalf, and it will automatically, each time it plays with the sliders, it gives you a score. So Refinery does this in 4 ways. And actually, I really like Refinery versus like tools like Galapagos or Octopus or Wallacey, because it gives you the option to play with these 4 things. Option number 1 lets you make options. It says, I'm going to randomize your sliders. And so it'll play around with the sliders and it creates your design space on the X and the Y axis in terms of options that you can make. And you tell Refinery, stop after, in this case, 5 options, but you could say 5,000 options. It doesn't get you to high performing options automatically. but it will show you where they sit in your design space, and it will show you how they perform. It just won't curate them or evolve them to higher performing. Then there's cross product. This one's also fairly straightforward. It says I have 5 in this parameter, 3 in this parameter, and I'm going to make all these options. Great. And again, you say as a user how much samples you want to see. Then there's the optimize option. So you say how many generations you want and how many populations inside of that generation you want. And the software will start to make one generation, evaluate how well it performed, and then see which sliders were better. And it'll say, oh, slider 1 is better when it's over here. I'm going to try that one again and see if I get better performing options. So we'll repeat until eventually you start to see special ones. So you can see that in the random, these ones did not show up. It's only here when the software iterates on your behalf that it can find these higher performing options. And this fourth one is the one I like a lot. It's called like this. So if you've ever played with sliders and Dynamo or Grasshopper, sometimes you find a spot that you like. You're like, oh, those are good. And you don't want the software to mess around too much because you know it's going to be good there. So this one is like, okay, I know that I have these ones here. Great. Now I'm just going to wiggle the parameters just a little bit left and right because I know there's some good ones around here. So it does a little bit of option for you, but you say, give me a band to say how much it can be like this. The real magic comes in the optimization. This is the one where the software uses a genetic algorithm. Everything else is just optioneering. There's automation, but there's no decision making by the software. The optimization is where the software observes the goals and it observes how well it scored to those goals. And it says, oh, slider 1 is better over here. Let me try again. So it learns which one is better. And so that's where it starts to, over time, get you to higher and higher performing options with that genetic algorithm. So to break it down graphically another way, if I have generation 1, all these different populations, number 2, 7, and 8, these ones are really good. It then says, okay, great, I'm going to take those, learn what the sliders were, and remake a new generation. And then it will again pick the top candidates, and then it will sample their DNA, again, their parameters, the sliders, and it will find new options until you can keep repeating this. And the goal is that by the time you reach generation N, 10, 20, 10,000, you should have higher performing candidates that are probably not what you expected. So like the good example is like slime mold. It's like lots of options are made, but only the really good ones are reinforced. So this is slime mold going towards food, and it's shooting, you can see all of the options everywhere, but then it stops and it only finds the really good ones. Slime mold behaves just like a genetic algorithm. So whenever we're talking about how you can talk to your clients or your customers or even your team about like how does generative design affect your work? Usually what happens is that most of the time architects are in here. You know, like if you've ever seen Rem Koolhaas' Office for Metropolitan Architecture, you see he has interns making lots of options, lots of iterations. And sometimes that's cool, but most of the time, designers want to think about the concept, the goals, and then they want to have fun with the details and curating what examples they've made. So what generative design does is that it pushes more time for the designer to be in the concept and the detailing phase. And so I was just going to say that if you haven't already seen this example of Project Refinery for Dynamo, you can come here to this website to try it out. And then I was just going to talk a little bit about the technology centers to see if, you know, anyone would be interested in how this could support their work. So the technology centers are basically a place where Autodesk helps external teams to explore future of making. And we bring together everybody. They can be academics, they can be in construction, they can be in fabrication, design, and we really want to help them to make innovation, like using generative design for a problem. We basically provide the people that join this outside network. This is like a network of participants, and Autodesk gets a view of what people are doing in the future. In order to see that, we give them a lot of resources at no charge. So right now we have 3 centers physically. I'm in Toronto, but we have one in Boston and San Francisco. And we have lots of different workshops that we talk with. And now we're starting to make places where we can support new participants of the network in those locations with Autodesk offices. So there will be some in Tokyo, some in Singapore, Melbourne, Sydney, Birmingham, UK, Munich, and Barcelona. And right now we have 450 teams that have been in the program. These are 350 organizations. They could be startups or academic groups, labs, customers. We've had 20 different countries, and we've had 2,000 residents so far. So who is joining these programs? Really, they're broken up into designers, engineers, developers, and executives. So we have industry groups like Takanaka, which is in the program. We have big companies like Unity, which are joining. We have Harvard and MIT. And we have lots of other groups, even like robotics companies like ABB, scanning and lasers like Faro. So why do these companies join? Well, if you're an industry, you would basically use it to do an innovation project. So in this case, GHD Engineering out of Australia, they're basically getting to try new technology with the support of Autodesk. So here's an example of Thornton Tomasetti. They are a big engineering office in US, and they're working with a startup company out of Russia to make this 3D printer of concrete. And it's great that they have a 3D printer of concrete, but what's really important is to be able to get certification and engineering standards for these concrete walls. So here's a before of how CMU block or concrete masonry units would compare to the concrete printer. And so they basically have to come up with the engineering specs. They're working together now, these two residents. Academic teams, sometimes they host special courses. We're starting to get the University of Tokyo to be interested in joining the program. A few different labs are interested. A good example is AMBOTS out of the University of Arkansas plus ETH Zurich to have mobile robots to print big examples. So lots of robots working together to make bigger projects. If it's entrepreneurial or startups, basically like this company, they're making robots for underwater or challenging conditions in outer space. They work with NASA, they work with the Office of Naval Research in the US. And for them, this was a great program to help them prototype lots of different robot options. And finally, network. We have, I mentioned, companies like Unity, Boston Dynamics with the Spot robot, Microsoft HoloLens, and the Association for Manufacturing Technology. We work together with them to promote some programs that are similar to both companies and or organizations, and we can work together to promote each other and to make interesting programs. So how do the technology centers help? Well, we connect teams together. We can advance their knowledge of technology and even in some cases grant them some technology. And we help them propel their innovation. So we usually offer teams all of these different things. I can share some of this afterwards. But examples is here. We have basically like we do design critiques or feedback sessions with residents. So in this case, this is someone who has a design and we're saying, oh, maybe you want to use this CNC or this mill instead of another one because you might get a better finish on your product. We can show different examples live in the demonstrations. We bring everyone into our Slack at Autodesk. So in this case, we're working with GHD Engineering to look at some machine learning for their drawing sets. And in this case, we're even able to give them snippets of code in Dynamo and even here, so we can work directly with you on Slack. We can give a little bit of training. We don't cover all the products. Autodesk has a lot of products, but we do support a lot Fusion 360 to help people to make things. And we like to elevate resident work, so promote resident work. So we have a Vimeo channel that we basically showcase lots of different teams doing their cool work. Examples of outcomes from sharing work is that Follogram, they develop augmented reality holograms. Actually, Yuko, you might remember this team from RobArc 2018. They were the winner of the workshops.
Yeah.
And they're now a resident. And they gave a presentation and then they got to work with a construction company out of Boston to use their tools on site. We also host panels to talk about topics. Like in one case, it was design and construction for mass timber. And it was really great. We had a lot of different insights from architects, supply chain, designers, all talk about what the impact of mass timber will be. And then we promote our residents also with Autodesk publications. So in this case, We will sometimes showcase that project with the robotic company 3D printing concrete. They're in Redshift, even in Japanese. Hone Structures, the generative design company, they were also doing stuff. So lots of examples of how we can help promote your work. And if you're interested, you can see this URL here, autodesk.com/technology centers. And if you want, you can apply, or you can reach out to me at any time and we can talk about your project. So again, I'll stop here for now and see if anyone has questions.
Thank you very much. 今のところでテクノロジーセンターについて質問がある方いらっしゃいますか? Do you have any questions so far? Okay, then I have a question.
Okay.
So, Technology Center in Tokyo, we have, do you have Technology Center in Tokyo, and do you plan to have any physical location in Tokyo as well for the Technology Center to gather? Is it now in Autodesk office in Tokyo, or where in Tokyo for now?
So we have an office in Tokyo, but it will not be a physical laboratory station. Because of COVID, we are not yet looking at new laboratories yet. Maybe in the future, but not right now.
Thank you. 他に誰かいらっしゃいますか? リスさんどうですか?
It could even be questions about Refinery if there was questions about the tool.
Can I ask about generative design?
Of course.
In general?
Yeah.
So actually not about generative design, but what do you think is the future after generative design?
That's a good question.
Because it seems like it was like parametric and then generative design and then what's next, but
I think another big step after this will be to start to get designers off of a two-dimensional screen. I think what may be coming up after as a major breakthrough in design technology will be designing in extended reality.
Oh, I see.
So this could be designing in virtual reality or augmented reality. So instead of you sitting at your computer with your mouse looking at a screen, you can design in real space, and then you can combine it with tools like performance analysis or generative design. But you're designing it as if it's the human scale, your scale.
I see. Oh. Okay.
Good question.
Thank you.
My pleasure.
Is there anything that you can share from Autodesk that's something like that, or planning to have a, I don't know, platform or software or something?
Yeah, I mean, technically Autodesk has a tool called Forge, which allows you to develop essentially your own custom APIs to go between programs. So there's a lot of different ways in which that you can leverage data computation and connect different software together for It could be things like viewing, either in virtual reality or augmented reality. It could be to develop your own automation scripts that run in the cloud. So if you're interested in like where Autodesk is thinking about stuff next, Autodesk Forge is going to become a very big interest as we become more platform.
Okay, thank you.
My pleasure. Anybody else?
どなたかどうですか？質問等ございましたら、質問もしくは感想でも大丈夫です。Okay, everybody is so shy.
Oh, if you have time, sorry. If you have
Yeah,
time,
sure.
Can you explain more about the refinery?
Of course,
a little bit
of
more
course.
because I'm not quite. I knew about the product, but I've never really used it. So, is it a part of Dynamo or is it a separate thing in Revit? Or
Good question.
yeah. I use Revit mainly, but
Okay, so Refinery is basically just the engine that allows you to do generative design. If you have Revit 2021, Refinery is already bundled into your Revit interface. So it should look like this example here, where you will see under Manage, you'll see your generative design menu pop out.
Okay.
For those of you that are using Revit 2020 or earlier, you will need to get Refinery through Dynamo. I mean, technically you can use it both ways. It's just a difference in terms of UI. So leveraging Refinery via Revit basically simplifies some of what you add in terms of parameters and constraints just through a simplified UI. But if you want to make the geometry more from scratch and you want more control over your script, my recommendation is to leverage Refinery through Dynamo.
So I have a question for the generative design as well. In Grasshopper, we have Galapagos, and that the solver, we have two types of solver, evaluationary solver and simulated annual solver. And sometimes the algorithm evolutionary solver doesn't really work well, and different the other solver called simulated annealing solver works better because each parameter doesn't have how to say relation. So it, I use quite both solver, and I found sometimes really easier to work on the other algorithm. So so this generative design, do you have any option to switch the solver or the algorithm for finding options?
That is a good question. Right now, the simple answer is no. You as a user do not have the option to tweak the way that the algorithm works. So if we go back to here, in Galapagos or Octopus or others, like I'm also usually experimenting with tools like Wall-E, for example. I can change reproduction selection, crossover, and mutation.
Mm-hmm.
I can. I don't know if I really always need to or want to, but with those tools I can. With Refinery, there is plans to make these
Mm.
4 elements exposed to the user,
I see. I see.
but they wanted to make it simple for now
I
so
see.
that more people can experiment with it without
Right.
worrying about too many parameters to
Parameters.
set
Yeah.
up a
Okay. Okay.
study.
Yeah. I understand. Yeah. In the future, hopefully, this is more like a request, but maybe different type of algorithm
Hmm.
to experiment, and also this parameter is really. I think it's really important when you use generative design or form finding type of approach. When you use you you always end up those little parameters to change and find a better solution. So this tweaking parameters, not only the geometry or finding the goal, also the algorithm itself, you end up to experiment. So yeah, I think that approach if
Yes,
we have is great.
I agree. I think it's a tricky balance of trying to
Yeah,
make it simple, but then give people more
right.
tools. But yeah, even for myself, I prefer to have more tools, like access to reproduction, selection, crossover, mutation, and switch my
Mm-hmm.
algorithm. I know that Autodesk is using NSGA2,
Mm.
but they have a modified version of that algorithm.
I see. I see. Yeah, yeah. In the project, when you join the project, and then you when you use these tools, then the client's also asking that what is the algorithm and that little bit
Mm,
deeper. So like it's really great to have more example to those like quick and easy way to experiment generative design, and to let people know the concept. But at the same
mhm.
time, the real project, I think it's also good to have the detailed version. So if we have like, we can switch in a what is a simple version and little bit deeper version would be great, I think.
I agree, and I'll definitely pass that directly back to the refinery team.
Hmm. I think
Because the
we, yeah.
more examples we have of people requesting it,
Mm-hmm.
the more you can influence the tool. So, like, if you sign up for the beta,
Yep.
you can leave comments as well. But I will take both your comments and pass it back to the refinery team because I have them on Slack. It's very easy, and if you join the
Great.
program, you can meet them. They're all
Yeah,
very
I
nice
would love
people.
to. Yeah. And also, I would love to make examples and really want to share this idea and background history in Japan, because we really interested in those scope, but we just seeing that this happening abroad, not in Japan. So we
Right.
always thinking like this is really cool in the future, but in Japan, that the kind of conversation really
Mm.
happen always. So we really want to make, I think all of us in our meetup group really want to make example to share this idea and present what is the next of parametric design. So yeah, we thank you for the presentation. Really, really like exciting, and I would like to share this story to others and clients. So yeah, that's really what to say. Uh, Fascinating presentation. Thank you very much.
Good, good. I'm glad. Thank you so much for inviting me. It was really nice to present to everybody and to hear
Mm.
your questions. And thank you for all for listening.
Thank you for. I learned a lot. Thank you very much. Maybe others. Sorry, I talk too much, and
That's okay.
I'm too excited. And yeah. 他に誰かいらっしゃいますかね。どうですか、ゆうしさん、最後にコメントどうですか？ いるか
あ、いなくなっちゃったかも。
あ、いなくなっちゃった。あ、OK。ユースさんいなくなっちゃった。あ、じゃあ、レンさん、ちょっと最後にちょっと取りまとめを。コメント。
Yeah, that was a great presentation. Thank you very much.
My pleasure.
I think a lot of BIM or generative design here isn't quite up to world standards, but I think that presentation really explained a lot. So hopefully I'll play around with it and give you feedback or maybe examples or something. Thank you very much.
That's awesome. Thank you so much.
Thank you so much.
Oh, how can we contact the generative design team, or how can we get more info?
Good question. So if you go to the project Refinery beta, I think you can sign up for basically providing comments. So I'm just going to toss this into the Slack, into the chat. So that's one way, is that if you sign up, I think it will allow you to leave comments. That's one way. And the other way is if you want to get directly in touch with them, you can also, with a project specifically, you could join the technology centers. And then if your project requires some additional support or guidance, I could make introductions to the team directly. And then you could meet with them on Slack or something.
Okay. Great, thank you.
My pleasure.
So for the learning resources, is this the same in the website? So this Refinery beta, you can find the videos and.
So the Refinery beta page is good, and I'm just gonna see if I can find. There was a wiki site which was also very useful. Let's see. One second, seeing if I can find it. Okay, so preparation, primers. Okay, so I'm putting into the chat here